If you want some good video lectures online, one guy has asked, do we have some good video lectures online? So there are many people. So you can go to IIT Kharagpur website, Professor Banerjee, I believe. Second must be Delhi, SC Datta Roy. Then who else? Maybe from Kharagpur itself, you should have TK Basu. Right. So there are many lectures are available on these topics. This is the fundamental course available everywhere. You can go to YouTube, NPTEL. Right. It's not a problem. Okay, answering some of the questions. So major thing which is left is assignment. So I'm going to give the assignment when the topic is going to be completed. So I'm going to link as I talk with Piyush and Manpreet and all people. Like we are going to have differential equation, then maybe Laplace and admittance matrix. But I yeah, I talked to Sashi and he told it's not required for admittance. Like it's very easy. That is what we talk. Like some people who are coming late, they don't know what we are talking before the lecture. So right. And fourth one is this cut set, loop set. This will make assignment number 2, which I am going to give on maybe on this weekend, right? And then like around 20-25 questions will be there, out of which I am going to ask 5 questions. Same questions will be there, right, in your assignment 2 exam, right? Sorry, yes, Aishwarya. Assignment 2 exam for assignment number 2. I don't know when do you want to have it. Marks. So I understand from your feedback. Everybody wants good grade, right? So grading is not a problem. Look, why do you worry about grade? You are here to learn, right? Right. So don't worry. Look. Okay. So like previously, when I was talking about, yeah. So when I was talking about cut set, loop set, we already learned that cut set is associated with KCL and its current equations, and in loop set it's associated with KVL, it's associated with voltage. Before this we have also studied something called incidence matrix, right? And the equation which is coming out of this cut set loop, and when we are writing the matrix we are going to call it Q matrix, this matrix we are going to call it B matrix, and this matrix we are going to call it A, right? So these are very well defined things. uh, there are few people who are thinking that it's a pretty high speed. I don't know, is it high speed? I'm asking every time. If it is like if you cannot understand something, please let me know, right? So all three you're following, right? Is there any problem? Just let me know. I can reduce my speed one more time. Like I can teach same lecture which we have talked about, this admittance and all these things, right? So there is no problem in writing these equations and writing the admittance matrix, sorry, incidence matrix, right? So incidence matrix is easy. Just we have to make sure that the the currents which are going outside the direction wise, all these are going to be positive one, which are coming towards the node, those will be negative. And that is how we are writing the incidence matrix. When we are talking about the cut set, where is the cut set? Yeah. So when we are writing the cut set, yesterday you are not there, but we found out how to find out the correct equations. So when you are looking at the cut set, there is one more theory or one more thing which I haven't told you, but as we are going to solve the questions, we are going to talk about that. So the question was by Swarna here. Yeah. So you asked some question last time. So that question was at the end of the lecture, so I forgot to answer correctly. So you are saying that can we cut 6 or not, right? Right? Okay. Komal, right? Yeah. So Komal asked. The only thing is, in hurry I told yes, but the thing is, here you cannot cut 6. The only reason is when you are cutting the any any particular twigs and cords, what you need to see when you are cutting it, that part needs to be come out. Like if I am cutting this, then there are two parts. Part one this side, part two this side. I can take it out. If I am cutting from here, I can take it out, like the middle part, I can take it out. There is no problem. This part is outside. But which side this part is? It's not going outside, right? So last time I thought it will be both the side. That's why it's possible. So there are n number of cuts you can make, but the only thing is it has to go to in two parts. It has to go to in two parts. So you have to take it outside. So this part is outside. What about this guy? This guy is not, like, this is not the second part, right? This part and this part, how it becomes two part? It's not going two part, right? So we can cut the loop one more time and we'll see all the things are following this rule or not. So you can see that if I am having this tree, right, I can make this tree. All other are, these are the twigs, red colors are twigs, black colored are cords. So I can make cut set such a way that there will be two part, and I should make sure that there has to be only one twig in a in a in one cut. So if I am cutting this twig, that should not be cutting off one more twig, right? So I can cut this one this way, right? If I am cutting this way, there are two parts, one going this side, one going this side. This separate. So then I can write down cut set equation. Similarly, for this one, I can cut here. But for this one, how I am going to cut? Okay, third part. How I am going to cut this? Hmm? No, no, it has to happen. Look, because in single cut you will have one twig and so many other cords. Look, this is very small graph. That's why you are seeing difficulty. Otherwise, there are n number of cuts are possible. That's why I have taken this tree. So now tell me, can't you cut like this? Right? So you have to be a little bit like imaginary, where you need to cut and you will have two parts, right? You can have more number of cuts, and this is not only the unique solution. Maybe in three nodes you are seeing only unique, but there will be more cuts are also possible. But you have to make sure that one twig and more chords, and you should cover all the twigs one by one. If you want, let's make one. So this black are twigs. Now you have to make cuts for 2, 3, 4, 5. Now can we start with 1? Right. No problem. What about 2? Look, if I am doing this as you asked me, so there are 3 parts. This line is alone, right? So you cannot do that. Again, I am answering your question. So you cannot make the circular one. Hmm? So this is not possible, right? So you cannot take this chord. Sorry. Okay, how this is okay happening? So let's remove all. Okay, okay. Sorry. So this is not a problem. So at 2, I can make, let's say, cut like this. But you can see there are basically 3 parts when we are doing this. So what is happening when I'm making the cut? Can you see? There are 3 different portion of the graph. 1, 2, and this one is third. And rest is 2, right? So this is not possible. So as I told you, circular is not possible. Or even if I am doing this one, this is also not possible, right? Because there are not 2 part, which is like, this is not the one which is 2 part. It's actually also how to answer this now. Okay, one more thing. Okay, so when I'm removing this, let's say this twig has to part of this one also, right? When I'm cutting here, if it is not part of this, again it's not 2 parts, right? Are you following or not? The thing is, when you are cutting this, now I am making one more rule for you people. Let's say if this is 1, 2, and 3, I am cutting 6 also, but 6 also has to part of this one, right? When you are cutting it in 2 parts, both the parts are part of part 1 only, so that is also not allowed, right? Now are you following? Because some of the rules are not written in any book. I have to invent on the basis of your questions. Right? So this is second cut. What about this guy? Let's forget about this one. So can you make it for 3? Yeah. So how it will go? There may be another option also, but this is also one cut set, right? Right. What about 4? No, no. Look, there is only one twig and others are cord. Oh, sorry. This is not required. Yeah, I made it in hurry. Right? Okay. What about this guy? I need to see whether I can make it or not. Mm, is there any way? Sorry? No, maybe I made some wrong graph. If it is not cutting, then yeah. 0, 5? Line between 0 and 5. No, no, 4 is not allowed, right? Okay, yeah. Because of this, I was not able to see that, but yeah, what Komal is saying is correct, right? This is what you are saying, right? So this is how you need to cut the graph, and you will have like all the equations. Do you want me to write these equations, or if somebody could not understand, please let me know. This is the most fundamental thing, and sometimes if you are following differential equation or Laplace or just nodal equation, that will not work. and you will not have the transfer function correctly, right? Yes, Nakul. So we are meeting after a long time. Means inside the class. Huh? Okay. Okay. Otherwise, we are meeting outside. Yeah? Some guy was writing, I'm talking too much about out of context, which is not part of ee203. So sometimes people are feeling bored, right? Just I'm talking about ee203 will not work. Don't worry, I'm taking all the comments very positively. So don't worry. Okay. So if there is no problem, let's look at the problem, which is loop set. I'm making, okay, it's better to make it one more time. So all these are twigs. Let's name them 1, 2, 3, 4, 5. Let's name this one as 6, 7, 8, and 9. Right? So after understanding the cut set, let's talk about loop set. So loop set has a reverse rule which we had for cut set. You will have only one chord and many twigs. The direction wise, you are going to follow the chord direction, unlike the case of cut set where the direction was of a twig. So we are going to have how many loops in total? How many loops we are going to have? Four valid loops will be there. Four valid loops, right? Because we have four chords. If there are four chords, means you need to write down four different loops. If you are writing four different loops, so let's talk about the loop which is covering the chord 6. Only chord 6 and other will be twigs. So one possible loop is, right? So in this case, all these which are going in this direction, so this will be negative, this is positive, right? When you are, yeah, it's a direction of chord. So chord direction is 6. So unlike the previous case when we were looking at the direction of twig, right? Yeah. Any doubt? Any doubt? Okay. What about the chord 7? So it will be 1, 3, 2, 3, 7, right? 8, this one. Hmm? 0 to 2. No, no. Everything is with respect to this chord direction, which is 6. So when I'm rotating this, it will be in this direction. Look, right? If I am looking at this, the chord is in this direction, so I am going to follow this direction. If it is this, it will, okay. 8 is like this, so it will go this way, right? We are going to write some equation. Today we are going to write some equation for loop set also, right? And what about the last one? 9. Yeah. So as you are rightly pointed out, the direction will be of chord, right? No hidden thing. Everything is clear till now. Okay. So cut set already we talked. Let's do one thing very quickly. Somebody can help me to feed this Q matrix using cut set. So this side, these are the cuts. This side, there are the edges. If you remember, if you have marked the 1, 2, 3 correctly, 1, 2, 3, if they are on twigs, this matrix is going to be like this, right? You have to make sure that 1 2 3 has to be on twigs, right? Then this is going to happen, otherwise it will happen somewhere else. Okay, what about this 4 5 6 now? Somebody. So this is for first cut. Okay, 0 -1 minus +1. So you have to see this direction. If it is inside, it's inside, right? Now let's talk about second cut, right? Oh. Okay. -1, -1, +1, and the last one, right? So 4 and 5. 4 is -1, and 0. Why plus? No, it's going in a different direction, no? Look, 4 is coming this side. On this particular edge, it will be like this, right? Right? Okay. So book is also following what I'm doing, right? So it's same. Right? Okay. I'm writing loop set. Okay. So let's talk about loop set here. Please do not consider these circles C1, C2, C3. It has been copied from previous image. That's why it is there. Okay. So do not consider them. So we need to write down 3 loop set equation, and those will be, one loop will be this one. So can somebody tell me which direction it will be? The direction of 4, because that is the chord, right? About this one, it will be a same direction of chord, and you have to complete the loop. For 6, right? Yeah. If that is the case, and like we did some analysis through which we qualify some of the equations, right? Because when we are writing, there were more twigs, more chords which are not allowed, so we removed them, right? So these are the things. Okay. So this side you are going to have loops, this side you are going to have edges when you are going to write such thing, uh, like cut set, where first 1 2 3 we're getting such kind of matrix. You are going to get the matrix at the end at 4 5 6, because we are giving 1 2 3 number to twigs, and 4 5 6 or the last numbers to chords, which are going to forming this diagonal 1 matrix, right? So regarding this, can you tell me? So here, the first loop, you can see 2 is minus, 2 is minus, and 1 is in same direction of chord, so it's +1. If we are looking at loop number 2, which is this one, so 3 will be minus and 2 will be plus. Similarly, you can write down other, right? Okay. So if that is the case, there might be some places where you are going to see current sources and voltage sources as a part of your graph, right? Because all the circuits need some input voltage, right? Or some currents, or sometimes you will have, so these sources might be independent or maybe dependent. Do we understand dependent, independent, right? All the independent are the one which are available in our laboratory. All current sources, voltage supply, function generator, everything are independent sources. When it's dependent, it's like we talked about one circuit called voltage control voltage source, or this book is calling it voltage to current transducer, which is like this, right? This was diagram for MOSFET, but for BJT, you may have So this current is dependent current source, right? In case Thevenin and Norton, we were not including those things like independent sources. We used to short all the voltage sources, open all the current sources. But in this case, we are going to consider such independent sources also in our analysis. We are not going to short them, right? So that is what I'm talking about. All the current sources has to be part of core tree. Now, what is core tree? So somebody can tell me very quickly what is core tree in here. Core tree. Yeah, yeah. Somebody told the correct answer. All the chords are core tree, right? Which is not part of tree. It's core tree. Sub sub tree might be part of tree, but which is not part of tree will be core tree, right? So let's agree upon that. All the current sources will go to core tree. So wherever you are saying any current source, keep it on core tree, and if you are saying any voltage source, keep it on tree. That will be that will make your analysis very easy. Otherwise, you can do some other thing also. You can exchange both of them. Answer will be same at the end. Okay, so let's assume there is one network which has also voltage source which is known as E, right? So we can draw the graph. I need to look at the directions what book is following, right? So book is following. Any problem in drawing graph is not a problem, right? So the directions are arbitrary right now. 2, 1, 6, all these are arbitrary, right? Now we want to write down following matrix. We want to use cut set and we want to write down q, but new q matrix will be known as q augmented with some extra entries which is coming because of voltage source and some current sources. So when you are going to write down, it will be voltage sources will be in first few columns. Thereafter, you will write down the whole cut set equation, whole cut set matrix, and then you are going to write all the current at the end. And how it's going to be performed? Let's look at that. So first of all, we need to cut the matrix. In how many cuts are required? By the way, Komal, what do you think? 4 cuts are required. So where are those 4 cuts? One might be this one, which is easy, which covers this twig. Can you cover this twig and create some cut? Hmm? What, 3? Right? Okay. What you are saying? 4. Okay, so the last one will be right. So the direction will be same as your twig when you are applying cut set, right? So here, right, when you are going to write this equation, 4 is coming in opposite direction of the twig E. Similarly for this one, okay, it will be in this direction. Okay, maybe we'll write about this one maybe when we are analyzing it, right? So no problem, right? So when we are making the first cut set, okay, when we are going to make the first cut set, you are going to have only one voltage source is available, E. So let's call this one is E1, and only one current source which is J. Let's write it down here, J. This side you are going to have how many AGs are there? There are 6 AGs are there, right? So you are going to write down 1 2 3 4 5 6, and this side you are going to have cuts. How many cuts we had? So 4 cuts. So we are going to write down 1 2 3 and 4. When we are making the first cut, it starts with this one, right? So can we write down what is happening here? E is 1 and 4 is minus. Rest of the entries are 0 for the first cut. There is no J also. Now you can write down for this one. I'm removing others so that there is no confusion. Right. So this will be this side, this will be this side, this will be this side, and this will be this side, right? So can you tell me what will be the entries? So 1 is already 1, no problem. Hmm? 1 0 minus 1. You just write down in your notebook and let me know. I'll copy that. Answer is already on. Okay. So direction is E. E direction. It's arbitrary again. No, that is not how graphs are working. But generally, like, you can give this also if you want. Other is also possible, right? Look, maybe you people are not convinced with one thing. There might be like a black box where there is V out and V in, right? And you are writing some transfer function, right? This is what you are doing. You never care what is happening in between V1, V2, V3 and the direction of currents and voltage, right? So we care about this analysis which is going to give me the final answer correct, right? So if you are doing this, the final answer will be correct one, because how can you how are you sure about the direction of these currents? If you are questioning this E, then like others are also arbitrary, right? It's not following the KCL. These are not the current KCL equations, right? But we are using that in KCL. This graph theory was a different study. It was study of mathematics, and then it has been used in computer science and electrical engineering, right? So here in this one, can you tell me what is the? I'll write down. Okay. Minus one, minus one, minus one. Right? You are considering J also, right? Okay. If this one is fine, let's go to second, which is like this. So the direction is second, right? One we did, so I'm going to second week, right? So you can write down these entries. Which one, two, three? This one. Oh, this cut or which cut? When I did this one, I was saying that this is cut one. That is what your question is. Cut one is on the basis of the twig number. This one is cut two. This was E cut. Cut E, which is here. We kept it somewhere else. Okay, let's. Right. Thank you. That might be better, like numbering, right? Okay. So can we feed the entire matrix, right? I'm leaving to you. Okay. So you are going to have these equations. Now there is one more thing just for completion. I'm teaching this topological formulation of nodal equations. Otherwise, we generally don't use it everywhere because admittance matrix is the most powerful thing. But just for completion, where you are going to have all the nodes will be converted to current form. using Thevenin Norton transformation, where everything will be converted to current. When you are doing this, where I'm interested in current, I'm going to write down two things. One is admittance times voltage. But you can see this B, this B, and this B, all B are same. And they are saying that for first node, you are going to have this equation. For second one, you are going to have this equation. If you want to make that, what exactly this equation means, for first number of node which is associated with transconductance G1 times V1 is going to give you I1. Rest of the things are 0 in this particular row. For second number, it's 1 by SL2, rest of the things are 0, multiply by V2 will give you I2. And similarly, you can write down for all 6 nodes, you can write down the associated impedance, and through which you can write down this matrix. This is generally a big procedure because this will give you 6 by 6 matrix. To solve this matrix, it's sometimes difficult. Admittance matrix is actually going to give you 3 cross 3, right? Right? It's just for completion of what we are doing, which is, okay, where is it? Where I was. Okay. So now let's draw some graph. Sorry? Okay. Which one? G1. G1. No, no. Look, here when we are writing this entry, the topological formulation of nodal equation, it's only take care of what is happening with respect to 0 ground. We are not looking in between, right? If you are writing here, it's SL2, this is 1 by SL3, this is 4 wala is coming from here, that is G4, 5 1 is SC5, right? Each node current, they are, okay, I understand what the problem is. Okay, so each one of the current which is flowing through particular element is going to be considered as the current. So if this one is I1, if this one is I4, this one is I2, this one is I4, this one is I3, I6, right? If these are the things, you are going to take care of only one particular node, which is, you are calling it V1 for this case. So G1 times V1 is going to give you I1. This I2 times 1 by SL2, sorry, 1 by SL2 times V2 will give you I2. And if you are talking about this G4, that will be G4 times V4. That is the internal node. Internally, when we are going to simulate it, we are going to create it. That is how this topical formulation is happening. What have you studied in topical graphs? You told me this topic, that's why I went very quickly.
Basically, it was like starting from somewhere that doesn't have a back edge.
Hmm. Okay, so when it's electrical formulation of this topological nodes, what we are doing, we are considering V4 is happening in between somewhere. It's internal node for the simulation, and that is how they are writing the equation. And then they are transferring this to again admittance matrix. This was invented before admittance matrix, but the admittance was is now actually more popular than this topological one, right? As I told you, I am teaching you just for completion. There is also one topic. I should not drop that, right? Okay. Still, it's same uh, same circuit, and in that, if you want to make a graph, you can make the graph. If we are okay, what next? Is it okay? Now, if I want to write down the matrix as we have written this one, which has extra entries like E and J, for that we also agree that the current sources will be part of core tree, all voltage sources will be part of tree, right? So all the voltage sources, if you are seeing anywhere voltage sources, it has to be part of twig, So this current sources has to be on cord, right?
So if there are multiple number of current sources or voltage sources on every arm of the circuit,
Mm-hmm. That is also possible.
how it's possible?
There are, we are talking about dependent, independent, both. We are not talking about only just one function generator. As I told you, there might be many transistors. Each transistor is composed of actually one current, which is actually dependent current source. So in this network analysis course, we are not studying anything which is transistor, but we are studying all the equivalent model of all such things which are going to give you current source, voltage source, right? So that all such analysis is going to be helpful when you are studying the real circuits, right? This is circuit analysis. This is not invention of any circuit amplification. Those things we are not studying, right? How to analyze that, that's what we are studying, right? So these might be some transistors, or these inductors might be some passive or parasitic inductor, parasitic capacitor. This might be some small signal model of any probe. It depends, right? So assuming that there might be like three current source, they are on cords. So now can you help me in making tree? As this book is suggesting, tree should be given 1 to 3 number, right? So you can choose this one, no problem, right? Yeah, Mahima. If you are taking anything else, the actually graph will be closed, right? So that will not be part of tree, right? So 1 2 3 are combining all this is going to give you tree. Others are chords. So it's also following the agreement which we made earlier, that J1, J2 and J3 will be part of chord, right? Okay. So if you agree on that, can we write down the augmented Q matrix, which is going to have now 1, 2, 3, 4, 5, 6 edges, and J1, J2, J3, three current sources. So if you are doing this, you need to have three cuts. When we are making the first cut, how it should be look like, no problem, right? I can do this. 1 4 5, and then yeah, you can take, no problem, there is no problem. Okay, so as Mahima likes this one, okay, no problem. Then you need to rename these as 1 2 3, and let's call this one 4 5 6, right? Okay, so now can you tell me three different cuts? No problem, right? Second cut, this one. Oh, sorry. What I'm doing, right? Okay, that's the biggest achievement if students knows more than teacher, right? Okay, so then if you are following this, can you tell me what will be the direction of first cut, right? So if this is the first cut, you are going to have 1 0 0 0 0 0 0 1. So 4 5 6, 4 is 1, 5 no 5, 6 1, J1 minus 1, J2 J3. Hmm? Oh, J3 1. Okay. Right. Okay. So generally, there is some. Okay, somebody wants to know how I'm checking the paper also, right? So if somebody made some mistake, and I found out that he made some mistake unintentionally, so I give some marks. Okay, Right? Do you want me to not give marks or whatever you want? We'll follow that. Hmm? Huh? Okay. So, there are few guys maybe who wants to know how I'm going to evaluate their question paper. Huh? Okay, no problem. Yeah. So this is how it will go, right? Do you want me to write down for this one? Let's say this is cut 2. Cut 2 will be inside, right? So can you tell me what is going to happen to rest of the entries? Zeros, 1, right? What about this one? 3. 4 is 1. 5 is 1. 0. So minus 1, minus 1, minus 1, minus 1, 0. Right? That is how it will go. Okay. There is only one topic which is left. Those who are studying control, it will be linked to that. Okay. It will be useful for control also. That we are going to study maybe on Monday. Sorry, Tuesday. Right? And you are going to have your exam mostly on 21st lecture. So which is happening on 6th of April. 6th April is, I don't know, Saturday or what. So Saturday is possible to have the exam.